Today I'm going to discuss a problem from the Codeforces Round 958 Division 2. Okay, so this is the C problem from the context, that is increasing sequence with fixed order. Okay, so let's see the problem statement here. Now, we have given a positive integer n, and we need to find the longest sequence of positive integers. So this is the sequence. We need to find this, and it must be what? Longest. Okay, that satisfy the following condition and print the sequence. So we have given few conditions. We need to find a sequence that satisfy these three conditions. So the first condition is what? A must be less than equal to 1. Less than equal to n basically. Okay? Now A should be what? Strictly greater than, like strictly increasing. Okay. Means AI should be greater than of AI minus 1. Now the third case is what? AI or with AI minus 1 should be what? Equal to n. So simply we have given three conditions. We need to find the longest sequence that satisfy all the three conditions. So this is the problem statement. So let's take the example test case. Let's take the 23. This is the example test case. Okay, 23. So you must be thinking we should proceed from like 1, then check for 2, 3, and start like finding pair of something like array of something like this. So what I did was simply see all the output of the cases. You will gonna observe that n will always be a part of my answer. Okay, if you observe all the cases, you will gonna observe that n is always be a part of my answer. So why not to start from the last itself if n will always be a part of my answer, which is like very obvious. If you have like something like this, okay, this is my n, and if I take orbit of any element that is less than of it, will like gonna give me this will like always be a part of my answer. Not all the elements, but that will a part of my sequence, and if I take them or with the n, then it will always gonna give me same answer basically. And okay, so based on this observation, I did what? I started finding the element from the last. Now, since I have 23, so let's think from the binary representation of it. Okay. So what is the binary form of 23? Is basically it's 110111. I think this is the form, or I did write it wrong. 16, 8, 24, sorry, 16, 4 plus, okay. So this is the binary form of 23. So how we will gonna perform operations. So see, first do what? Make the flip the last bit of it. I'm going to like flip only set bits. All right, I found one. I'm going to flip it to what? A 0. Okay, and its value is what? 22, and its value of 23. Now you will gonna observe, if I take or of these both now, I'm going to get the same value. If you don't know, the or operation is what? If you found a, let's say a and b, if I found a and b both are 0, then in that case my output will be 0. If I found 1 0, then it will 1. Like for all the cases it will be 1. Only if I found, if my a and b both are 0, then in that case it will be 0 only. Okay, so I think the or property was clear to you. So let's see here. I found my second number. Okay. Now what next? Simply flip this. Now flip this bit, and it will become what? 1010. And you have flipped the last bit at the like previous step, right? So flip it back and make it 1 again. Sorry. So let's check. Do I'm going to get or not? If you take the or of these two now, then you are going to get the same number, that is 23. Now what is the like 145 and the 16, that is 21. So its decimal form is 21. So this is my third number I got taken. Now I have flipped the last bit, this one earlier, right? Now let's flip this bit and unflip this bit back. Okay, so what I'm going to get? I'm going to get 10011. Okay, if you want to flip it back, then in that case you won't be able to make an basic like 23 there. Or okay, so we need to flip it back as well. I need to make it back. Okay, so if you wanna see again, if you take all of it now, so you will going to get 23. So and this is what I want. Now what is the binary form of it? It will comes out to be I guess 19. Do the same task again. Now I have 0 here. There's no need to flip 0. If I found, I'm going to flip only 1. Okay, now I found 1 here, so flip it and make it 0 0 0 0. And I have already here 3 ones. So in that case, what? I'm going to get 7. So my possible sequence is what? 7, 19, 21, 22, and 23. So this is my valid answer, and I need to print this symbol. So I think the problem statement is clear. Let's discuss the approach again with the new example test case, that is 14. So let's take the recap of it. Okay. So I have 14. What is the binary form of 14? it will be represented as something like this. I will start from the back. If I found 0, I'm not going to do anything. If I found 1, simply flip it and make the new character that is 1100. Okay. Now I was previously at this index, now move to the next index. I found 1. Okay. Simply flip it and unflip the previously flipped element. That is, I have previously flipped this, so unflipped this. So it will now become 1010. Okay. Now, previously I was at this index. Now move to the next index. Next index is what? This. Flip it. Now it will become 0110. Simply check if you're getting the correct or not. It was what? 14. And this is what? 12. This is what? 10, I guess. Okay. And this is what? 6. If you're going to take XOR of like in the sequence, now then you're going to get the same answer that is 14 previously. Okay. So I think the approach for the problem is clear to you. So for this, the answer was 6, then 10, then 12, and then 40. So this is the answer for this case. There can be like valid other answers as well. If you're gonna see here, have like different answers, right? We have different answers here. But if you see my answers as well, these are also correct. These are also satisfying all the three conditions. So yeah, there can be different answers. You need to print just one answers. So let's take the look at the code of our. Okay. So firstly, what I'm doing is simply correct your decimal number into binary form. How? Here I have a code for like converting decimal to binary. Simple, take the input n into the function, and then if I now I'm going to divide n by 2. If I found 0, if the module of it was 0, then add 0 to your answer. Basically, it's a simple math. If you're gonna see or like look at the video for anything, you are going to get easily. So this function is returning the binary form of our like and again. From here I'm going to get the binary form. Once I got the binary form, what I'm doing, simply reverse the binary form. To make the calculation easier, I'm simply reversing. In the example, let's say I have 1011, right? I'm going to flip it because I was going from there. Okay, I can do that task as well, but to avoid unnecessary problems, I did reverse it, and then I'm going to perform the task from there. Okay. Now what next? I have took the previous index to maintain like previously flipped bit. What is the index of previously flipped bit? That's it. Now what I'm doing, this is my answer. And in this, I'm going to insert all the elements. And I did insert n first of all. Now I'm running a loop from 0 to a dot length. Okay. If I found a of I equal to 1, then this is the time to flip this bit. So what I'm doing is, if I haven't, let's discuss for later again. If, if I found what ai is equal to 1, what I used to do, I used to flip it to 0 always, right? If you see here, I found this one. What I used to do, simply flip it to 0. Okay, I did flip it to 0. Now here the previous index previously flipped what I haven't flipped anything before it, so it was -1. So no need to do anything. But if you see the next case, here you have what 1 and you have flipped it. If you're gonna flip it, it will become 0, and I need to flip it back. That's why I'm maintaining a previous index, right? So the same thing I'm doing here. If I found ai is equal to 1, simply subtract it from like ठीक है. If I have anything previously, first of all, look, subtraction. If I found a is equal to 1, I need to subtract this what power of 2i. What exactly this means I'm doing is, if you wanna observe this calculation carefully, you will observe I am at this index. I am flipping it, right? Now it is becoming 0 and it is at 0th index. Now 2 raised to power 0 is what? 1. So I need to subtract 1 from this. Basically, subtract 1 from 23 to get this number. Okay. Suppose I want to flip this bit. So how I can directly calculate the what next number I'm going to get? It's pretty easy. Simply found a number like it was 23. What is the index of this bit? It's 2. Now 2 raised to power 2. It's 4. Simply we need to subtract 4 from it and add the previously flipped bit so to get the final answer. This is what exactly I'm calculating here. Okay. I'm doing what? Simply subtract the power of 2 of that index. Okay. At which index I am currently, and I want to flip it. Okay. Now I need to subtract. When I have a previously flipped bit, I need to unflip it back basically to make it 1. So I'm going to add that value to my answer as well. And simply assign the previously my current value. Okay. And my n value of n should be what always greater than 0. So that's why this condition. And at last, so if you want to check out the code for each problems, so I have added the codes for ABC problems here along with the comments. So you can check the codes from this website. Okay. So the website, you will find the link in the description.